Okay, our last lesson of this chapter is the distributive property, and here's the big secret. If you learn to use this, it'll solve all sorts of problems when you get into algebra. It's kind of like a game where you have to rearrange things to be able to go to the next step. So let's look to see what this little secret of the distributive property is. So what we're saying in the distributive property is that I can talk about multiplying and adding or subtracting in two different ways. And I can rewrite it and they'll be equal. They mean the same thing, but if you're in algebra, you'll see the advantage of being able to do it this way. If you're just dealing with whole numbers, like here, there's absolutely no advantage of writing it one way versus the other way. But let's just look at this. So here we're saying we have 3 sets of 2 and 3 sets of 5. Down at the bottom, we're saying we have 3 sets of 2 plus 5. So it all depends whether we're looking vertically or horizontally at this, how we talk about it. So that has some advantage, but mathematically, it's not making things easier or harder. I still can say I have 6 plus 15, or I have 3 times 7. Either way, I've got 21. All right, so let's look at to see how this works out in algebra, because that's where we're going. For the most part, there is one other little trick that we use it for, and we'll talk about that at the end. Okay, in algebra, we're saying we have these unknown values, and we could use letters or we could use symbols, but we need to be able to write it back and forth in either direction. So if I have a star on the outside and a parentheses, that means that I'm multiplying whatever is inside the parentheses by whatever is outside the parentheses. I don't know what that number is, but the star represents the number. What's inside the circle and the square are two other numbers, and they're being added together. And that is the same thing as you saw in the last slide as multiplying star number of times by the circle number, and then adding star number of times by the square number. If I write that algebraically, it can look like this: A parentheses B plus C, or AB plus AC. Means the exact same thing. But what if I have this combination of constants and coefficients, and I want to partially, and we use the word simplify, partially solve a problem. I know I can't fully solve it because I don't know what A means. It's some number, but I haven't discovered it yet. But I know that the 6 and 8 could be constants, and if they're constants, they can be added together. So I'm going to make them constants. Now, watch this. Let me change my color here. I can give you this information on a test or in a problem in either way. I can start in this format and ask you to convert it this way, or I can start with this and say, please distribute it, and you will rewrite it, noticing that this right here is duplicated, and we actually call that a factor. It has the same factor. So we put our factor on the outside, and then whatever is being added, we put on the inside of the parentheses. Now, similarly, if we have the same format, a factor, which we don't know what it is, times a number, plus the same factor times a different number, we could rewrite it so that those two different numbers or constants no longer are the coefficients, they become constants. So it's probably not going to look like A6 plus A8 because, as you heard me say, we don't write algebra like that. We write 6A plus 8A. And we learned that that is a term, and it's like this term. They can be combined, and if you do that, you can see that we have 14A, or we can do it a different way, and we can pull out the coefficients, turn them into constants by putting them inside the parentheses. And then we can say that 6 plus 8, which is 14, then can be rewritten in its final form as 14A. Both of these equal 14A. In algebra, you're going to want to be able to move things around like this, combine them, and have a strategy. It becomes a game for those of you who get into algebra. It's really kind of fun, but you got to learn these little rules before you can play the game. All right, there is one more thing that you need to be aware of, and that is that we use this distributive property not for algebra, but for mental math. So what if I gave you the problem 5 times 280, and you had no pencil in your hand to solve this? You could use the distributive property. 5 is what we call the factor, and we have this 280, and if we split it apart into two constants, we could do it in our head. So if I said that this is the same as 200 plus 80, you could, in your head, multiply 5 times 200 with no problem. There's 1,000. And I'm pretty sure you could multiply 5 times 80 in your head and get 400. And then you could tell me the answer is 1,400. Whereas if you just looked at 5 times 28, I don't know what that is, you probably would have a harder time at least, coming up with the 1,400. So mental math is another way that we use this. We'll have some different formats as we practice, but this is the basics of what we're going to be doing. So I hope you took some good notes, and tomorrow we're going to go and practice all these different forms.